Good morning, children. Today also we continue the same topic of this increasing intervals and decreasing interval. In the last class we have explained that what is the how we can use the differentiation or derivative to find the increasing interval or decreasing interval. The summary of it, the recapitulation of it is: in an increasing interval f dash x is always positive, and in decreasing interval f dash x is always negative. So we will solve one or two problems of the trigonometric function also today. In the last class we have solved the algebraic expressions only. Suppose the given function is fx is equal to sin x plus cos x, or sin x minus cos sin x plus cos x. Okay, in the interval x is, that is the domain of the function is 0 to 2 pi. We want to find out the increasing interval or decreasing interval. What are the intervals where this function is increasing? What are the intervals where this function is decreasing? That is what we have to find out. And we know that we will be finding out the f dash x first, and sin x derivative is cos x, and cos x derivative is minus sin x. That is the first step. And then we find the turning point by taking f dash x is equal to 0. That is cos x minus sin x is equal to 0. So it comes cos x is equal to sin x. Cos x is equal to sin x. Which are the values of x where cos x is equal to sin x in this interval? That is what we have to find. Let us simplify further. From here, if you divide throughout cos x on both sides, so cos x by cos x it is 1, and sin x by cos x is equal to tan x. So you get tan x is equal to 1. So it is better to find out this expression, that is finding the value of x where tan x is equal to 1 in this interval. So which are the value where the tan x is equal to 1? You know tan 45 is 1. So one value is pi by 4. 45 is pi by 4. And which is other value? In this interval, this domain is given as 0 to 2 pi. Pi by 4 is the one value. Then tan 90 not defined, tan 135. 135 comes in which quadrant? It comes in the second quadrant. Tan is negative, so 135 it also not come, and 190, and you can see that the 225. Here you must remember this one: all positive, sin positive, tan positive, and cos positive. Now it is 1, so it is in the positive. Tan is coming as positive here, so it must be more than 190. So more than 190 and multiples of 45. That is the way of finding out. More than 180 multiples of 45. So 225, if you take, what is tan 225? Tan 225 is equal to tan 180 plus 45. Tan 180 plus 45, it is a multiple of, even multiple of 90. So tan gives tan itself. And in which quadrant? It is in the third quadrant. Third quadrant is tan is positive. So tan, it is also tan 45. So you get 1. So there are two values. One is pi by 4, 45 degree, and other one is 225. 225 means it is 5 pi by 4. So these are the 2 points where tan x is equal to 1 within the given domain, that is 0 to 2 pi. So pi by 4 and 5 pi by 4. Now using this pi by 4 and 5 pi by 4, we divide the domains. So what are the division terms? So it starts with 0, 0 to pi by 4, one interval. Then pi by 4 to 5 pi by 4 is another interval. Then 5 pi by 4 to 2 pi is another interval. So the given domain we have further divided into sub intervals. by using this turning point. So there are two turning points, we got the intervals. Now we will have to check whether which are these intervals is increasing interval and which are the decreasing intervals. So we will go by one. Let us take the first one. First one is 0 to pi by 4. We have to check whether this interval is an increasing interval or decreasing interval. Now we know that for an increasing interval, dy by dx should be positive, and for a decreasing interval, dy by dx should be negative. Okay. So for that, what we do is we take a point of this interval 0 to pi by 4. 0 pi by 4 is 45 degree. So 30 degree can be taken. 30 degree means pi by 6. So pi by 6 belongs to 0 to pi by 4. And what is f dash pi by 4? So we have taken a value of this interval, and check whether f dash at that point is positive or negative. Now f dash pi by 6, this is fx now. So f dash x. So cos pi by 6 minus sin pi by 6. Cos pi by 6, that is cos 30. Cos 30 is how much? It is root 3 by 2. And sin 60, it is 1. Sin 30 is 1 by 2. So cos 60 pi by 6, it is 30 degree. So cos 60 is root 3 by 2. Cos 30 is root 3 by 2. Sin 30 is 1 by 2. So root 3 by 2 minus 1 by 2. We don't require the exact value of that term. Just we want to see whether it is a positive or negative. Root 3 by 2 comes more than half. So more than half minus half, it is positive. So f dash is positive. So what we can say? We say that 0 to pi by 4 is strictly increasing. So what interval is over? Now second one. What is pi by 4 to pi by 4? Pi by 4 to pi by 4. Okay. Now pi by 4 to pi by 4. We should take a value in this interval. It is 45 degree and it is 225 degree. Let us take a 60 degree. 60 degree comes here, no? So pi by 3. Pi by 3 belongs to pi by 4, 5 pi by 4. And what is f dash pi by 3? F dash x. This is f dash x. So cos pi by 3 minus sin pi by 3. And what is cos pi by 3? Cos pi by 3, that is cos 60. Cos 60 is half. And sin 60 is root 3 by 2. Naturally it becomes negative. Half minus more than half comes. So it is negative. So you can see that which interval? Pi by 4 to pi by 4 is a strictly decreasing interval. So two intervals over. Now let us go to the third one. That is, what is the third one? Yes. 5 pi by 4 to 2 pi. Okay. So take a point of this interval. It is 225 and this is 360. Let me take 270 degree. 270 degree means it is 3 pi by 2 comes. It belongs to what? It belongs to 5 pi by 4 to 2 pi. And what is f dash? 3 pi by 2. That is s dash 270. Cos 3 pi by 2 minus sin 3 pi by 2. Cos 0, 1, cos 90, 0, cos 180 minus 1. minus sine 270. Sine 270, what is the value of sine 270? Sine 270 is minus 1. So minus of minus 1 will get positive. So what you can say is that this interval, that is 5 pi by 4 to 2 pi, is a increasing interval. So we have checked all the three intervals. So this is 0 to pi by 4, we got positive. So that is increasing interval. Pi by 4 to pi by 4 is decreasing. This is decreasing interval. And 5 pi by 4 to 2 pi, it is increasing. So these two is increasing and this is the decreasing intervals. So I think there is no chances of the confusion there. First we will be finding out f dash x and equate the f dash x, and then by get the turning points, and using the turning points we will divide the intervals, and then we will take each intervals, and in each interval we will check whether f dash is positive or negative. If f dash is positive, it is an increasing interval. If f dash is negative, it is a decreasing interval. I will work out one more question, and that was given as a yesterday's homework also. I think some of you are asking that I could not do like that. So let me work out that one today. That is, you are given the fx is equal to x plus 1 whole cube x minus 3 whole cube. It is a real function, that means the domain is R. R is the domain. We want to find out the increasing interval and decreasing interval. So let us find out f dash x, and it's a product of two functions. So normally what will be the first function into derivative of the second. What is the derivative of second? 3 into x minus 3 whole square, and plus second function into, that is x minus 3 whole cube, into derivative of this expression, that is 3 into x plus 1 whole square. Better you don't go for multiplying and simplifying, then it becomes more lengthy. You have 3 is a common factor for here and here, and x plus 1 whole cube is there, x plus 1 whole square is there. So let us take x plus 1 whole square as a common. X minus 3 whole square is there, x minus 3 whole cube is there. That means x minus 3 whole square is a common. So these two quantities, when you take it as a common factor outside, what is the balance here? X plus 1 is balanced because x plus 1 whole square is taken outside. So x plus 1 is balanced there. And what is balanced here? It is x minus 3. Okay, so now it is 3 into x plus 1 whole square, x minus 3 whole square, x plus x, 2x, 1 minus 3. So this is the f dash x simplified form. And we know that for increasing and decreasing interval, it is dy by dx will get the turning point. That means f dash x to 0 will equate and get the turning point. That is 3 into x plus 1 whole square, x minus 3 whole square, and 2x minus 2. That is equal to 0. So that means the product is equal to 0. So each one is 0. That is x plus 1 whole square is 0. That is x plus 1 is 0. And x minus 3 whole square is 0. That is x minus 3 is 0. 2x minus 2 is 0. From here you will get x is equal to minus 1. Here you will get x is equal to 3. Here you will get x is equal to 2x is equal to 2. That means x is equal to 1. So the points are, you mark like this in the number line. Okay, this is infinity and this is minus infinity. And you have 0 here and minus 1 here and 1 here, 2 here, 3 here. So now we are going to divide the domain by using this point. And this will be 1. So what is that? Minus infinity to minus 1 is the one interval. Then minus 1 to 1, this is another point. 1 is that. So minus 1 to 1 is another interval. Then 3 is also there. 1 to 3. 1 to 3 is another interval, and then the rest, that is 3. So we got 3 turning points and thereby 4 intervals. Now these 4 intervals are checked one by one whether it is increasing interval or decreasing interval. So let us take the first one, minus infinity to minus 1. The first interval. We have to check in this interval f dash is positive or negative. So what is the normal way? Take a point of this interval. What is the point of this interval? Minus 2 belongs to this interval. Minus 2 belongs to that interval. And we find out f dash minus 2. Here you have f dash x. Say f dash minus 2. What is f dash minus 2? Comes 3 into minus 2 plus 1 whole square, then minus 2 minus 3 whole square, then 2 into minus 2, that is minus 4 minus 1. That is f dash minus 2. Just check whether this is coming positive or negative. 3 into this is 1 and this is 5 minus 5 square, 25, and this is minus 4 minus what is that? It is minus 2 now. So minus 4 minus 2 minus 6. It gives negative because one quantity is negative. So minus infinity to minus 1 is decreasing, quickly decreasing. So that is, it is decreasing. It is decreasing. Now let us take the second one. Minus 1 to 1, the second interval, and minus 1 to 1, 0 is a point of this interval. So 0 belongs to minus 1 to 1. We will take the convenient value. Any point you can take within this interval. So 0 belongs to minus 1. Then what is f dash 0? F dash 0. We have to check here. 0 plus 1, that is 1 cube. Then 3 into 3 into 0 plus 1 square. Okay, then 0 minus 3 square, then 2 into 0 minus 2. Okay, this is 3 into 1 into 9 into minus 2. This is 3, 1. Minus 3 square 9 and minus 2. So it is also negative. That means the second one is also decreasing. Now see the other two. What is the 1 3? Say what the 1 3, we will take a point of 1 3. What is the point of 1 3? One point of 1 3, that is 2. You can take 2 belongs to 1 3. And what is f dash 2? Here it is f dash x. So 3 into 2 plus 1 whole square, and then 2 minus 3 whole square, 2 into 2 minus 2. And here it is 3 into 9. 1, 2 into 2, 4, 4 minus 2, 2 is 2, so it is positive. So this interval f dash is positive, therefore it is increasing. Now the last one, that is it is in 3, 4. I can take 3, 4, 3 infinity. I can take 4 is the value of this interval. Okay, so what is f dash 4? F dash 4 is 3 into 4 plus 1, that is 5, and 4 minus 3, that is 1, and then 2 into 4, 8 minus 2. It is positive, positive and positive, so it is also positive. So f dash is positive in the last nodes. So this is increasing. So finally the concluding answer is these two intervals are decreasing and these two intervals are increasing. That is all. So it is a very easy portion. It's a surely scoring topic for you to get the this. So some another 4 more questions I will share today for this.